So let's take a look at the kind of deformations that can happen. So when we physically deform these rocks in our mountains, there's one or three things that can happen to these rocks. They can undergo displacement, rotation, or distortion. Now, fortunately, it's really easy to see. For example, right, we know that when our rocks are deposited, they're flat-lying. Here, however, right, they are not flat-lying. So let's take a look at each one of these three. So the first thing that can happen is displacement. Right? Obviously here we've got a fault line and we've got one rock moving downwards in relation to the other. So displacement is a physical change in location. So if you notice on this picture over here we have a dark colored rock, right, on the left side, and on the right side we have a light colored rock. Right here what we're seeing is the same as what's in this picture. Right? We've got a fault line where this light colored block has fallen down in relation to the dark colored block. We can also get rotation. Right, remember, our rocks initially start out flat-lying. As you can see here, though, it is not flat-lying. It is on an angle. So obviously this rock has undergone some sort of rotation. But realize that rotation is also distortion. It's changing. It's a change in direction. It's a change in place. And our rocks can also undergo a change in shape. You can see here that my rocks are bent. Right? They are no longer flat-lying anymore as the way it initially started. Now most of the time in our mountain belts we're actually going to see all three things happening. So it's because our rocks are undergoing strain. Right? So strain is a change in shape due from the deformation. So here's some great examples. Right? And there's three different types of strain. So let's say we're going to start out here with a block, right? A cube, or a fossil, right? A shell. What happens when our objects here undergo stretching, shortening, and shear? So stretching is what we would see at a divergent boundary, right? So my fossil and my block here are getting stretched out, so it's elongating. Shortening, well, that would be convergent. So at a convergent boundary, everything is getting shortened, right? It's contracting, it's pushing together. So you can see it's shortening in a different direction. So really, you see that we have a rectangle here and a rectangle here, but the axis is in two different directions. Okay? And then we can have shear, which is what we find at our transform boundaries. And shear is where we're taking an object and we're pulling it apart into two different directions. So you see that we're actually elongating, right, but that axis is tilted. So our rocks can do one of two things. They can either behave brittly or ductily. So brittle behavior is what happens up at the surface. Right? My rocks are not hot, they're cold. And cold rocks are going to break easier. And that's what you see in this picture here. Right? You can see that these rocks, right, are all broken up, right, in different ways. So it's just like this plate that you see here, this plate that's been broken. And that's how our rocks behave in the upper part of the crust. However, if we look a little bit further down in the crust, our rocks are going to behave more ductily, meaning they're going to be able to bend. And they can bend because they are hotter. Right? Anything that is hot can bend easier. Right? Like the example we talked about in class. Right? If I have Play-Doh that's at room temperature versus Play-Doh that's in the freezer, well, it's much easier to bend the Play-Doh at room temperature. And that's what we see. That's ductile behavior. So my rocks that are further down inside of the lithosphere can bend a lot easier than the rocks that are up at the surface. So here, right, for example, we got a ball of clay, and we're going to put our heavy geology book on top of it, and it physically flattens it out.